Okay, so welcome to the lesson on solving equations. Now, you guys know how to solve equations when they are linear equations or quadratic equations, and we're going to use those sort of skills again, but this time we're going to solve equations that have these functions in them, like cosine or sine. So let's just have a little look and see how this will work. So here we've got a graph, y equals 3, cos x minus 1. So just to refresh on a couple of things, this 3 here is the amplitude. Okay, so the amplitude of this graph is 3. Okay, and the minus 1 is important as well. This is the vertical translation. So that is how far it's been moved up or down. So if we think about what this means, it means if we ignore the minus 1 for a second, if we were to plot that graph, y equals 3 cos x, x degrees, sorry, that's the degree symbol. If you were to plot that, okay, you'd get your normal cos graph, which is this cos bucket. But the amplitude means instead of the highest point being 1, the highest point is 3, and the lowest point is minus 3. Okay, so that's what the graph y equals 3 cos of x looks like. So amplitude is this distance away, from this point to here. Now, we've got a minus 1, and what that means is everything's been shifted down. So you can see on this graph, actually the highest point is 2, and the lowest point is minus 4. Notice how that is just this and this shifted down 1. So yeah, 3 shifts down to 2, minus 3 shifts down to minus 4. That's what this minus 1's getting at. It's suggesting that this graph has been vertically translated, it's been moved down by 1. Okay, so that's just the description there. We can actually see the graph plotted for us here. It wants you to find the points of intersection with the x-axis. Yeah, and again, we know from what just studying recently quadratic graphs, if you want to find where a line crosses the x-axis, you solve that equation and you solve it by setting y equal to 0. Okay. And we can solve this equation. So what we'll do is have a think about what's affecting the x here. We've got a minus 1, so we're going to add 1 to both sides. And we'll get 1 equals 3 cosine x. Okay, what else is affecting this x? Well, there's a 3, so we're going to divide by 3. 1 divided by 3 is a third. 3 divided by 3 is 1, so you're just left with cosine x. Okay, that's great. Now, we've seen the pattern here. We do what we call the inverse operation. So what's the opposite of taking 1? We add. What's the opposite of timesing by 3? We divide by 3. And what is the opposite of cosine? Because there's this cosine x. Well, there is an inverse operation, and I'll show you how to get it on your calculator. You press Shift, and then you press cosine. Okay, so on your calculator, press Shift, press cosine, and what that'll do is that's going to type the inverse function of cosine, and a little minus 1 here. And if in your calculator you type this, again using these two buttons, and then you type a third, okay, and then you press equals, what that's going to do is that's going to tell you what the value of x is. Okay, so hit equals, and you'll see that x is equal to 70.5. And again, I've rounded to 1 decimal place. Now, what that tells us, and let's just be careful about what's happening here, this point here is 70.5. Okay, but there are 2 values of x. And the way we're going to work out the other value is just by using symmetry. So you'll remember, okay, that this point here, this point of symmetry, where the cos graph is at its lowest point, okay, this is at 180 degrees. Okay, so if you type cos 180 into your calculator, you'll see that you get minus 1. And this is going to be true for this equation as well. that we've got here. Our lowest point is at 180 degrees. So what we're going to do is we're going to use symmetry. We're going to ask ourselves, what is this distance? Okay, so that's just a case of doing 180 take away 70.5, and that distance is 109.5. Okay, so it stands to reason that this point, because it's symmetrical, will also be 109.5 away. So this point is found by doing 180 degrees plus 109.5 degrees. And if you do that, you'll find out the answer is, let's find it, it's 289.5 degrees. Okay, and those are the 2 points. Okay, it might be worth rewinding the video and sort of seeing those steps again, but I would suggest that the main things are, first thing you need to do is solve the equation like you normally would by doing adding or subtracting and dividing, timesing, whatever it is to get this cos x by itself. So think of this as like step 1. Step 2 is using your calculator to find the inverse of cos, so doing the shift cos a third and getting this answer. Okay, and the third thing is to actually find the second point using the symmetry of the cos graph. And if the question draws it for you, great. Please use their drawing. What I've done here is absolutely what my exam script would look like. I would be doodling on, what they've given me in the paper. Okay, use it. If they don't give you this, draw it. Yeah, if they'd not given me this, I would have drawn this, I would have drawn that line there, and I would have still been marking these points on. Doodle it. Okay, it makes life 100 times easier to have a sketch. That way you can check it makes sense. And it's why it's important that you do learn how to sketch sine, cosine, and tangent. Okay, let's have a look at a different question. So here's a question, 7 cos x minus 2. So for a start, let's just think about this. This is the amplitude, okay? And this is the vertical translation, okay? So again, I've drawn a sort of cos graph here, okay? I'm going to sort of draw the axes on. And what 7 means is if you ignore the minus 2, we'd have, this would be 7, and this would be minus 7 here, your max and your minimum. But actually, that's not right, because the entire graph has been moved down by 2. So the maximum point of this graph is 5. The minimum point is actually going to be minus 9. Okay, again, notice how that's just, I've used the amplitude and then it's just been shifted down to. Okay, the frequency is not changed. So this is still 180, is going to still be this mirror point, and it's still, is going to be one full bucket by 360. This diagram that I've drawn makes the rest of this so much easier, okay? Which is why I'm putting such an emphasis on drawing this. Life is a lot easier now. Okay, so let's do this. What's the opposite of taking 2? What's the opposite of timesing by 7? What's the opposite of using the cosine function? Shift, cos. In your calculator, you would write this. Okay, and I'm going to do this now. I've rounded to 1 decimal place. Okay, I just want to be super clear. This is not a 0, this is degrees. I'm just being clear that this is x degrees. Okay, I just thought I'd throw that in there just to make sure that we're happy that this is just the degrees notation, just like this is, this would be 360 degrees or 0 degrees. Okay, so we've got 73.4. Okay, that's great. So we've got one of our answers, and 73.4 is this point here. Okay? So again, we're going to use symmetry. How far away is that from 180? So again, we're just going to do 180, take away 73.4, and that's going to be, that distance there is 106. Yeah, 0.6, 106.6. Okay, so that distance is 106.6. So this distance, okay, is going to be 180 plus 106.6. It's just the symmetry of it. This distance is 106, so this distance is 106.6. Okay, so if I just quickly do that, that's going to be 286.6 degrees, strictly. Okay, so I hope we're happy with that. Again, the steps there are: solve as you normally would, use the inverse function on your calculator to get this, and then the third, use symmetry. And again, it's just a case of looking at the graph. We know that we're finding the points of intersection. We know that this line of symmetry is at 180, so we can use that fact to work out what this value here is. And it's just a case of adding it to 180 for this question. Okay, so here we've got the equation 7 sine x plus 2 equals 3. Okay, and we want to solve this equation. So the first thing I want to do really is actually just write this out like this. So let's just bring it all to one side. Let's take 3 from both sides. Okay, because this is slightly easier to sketch, because our magnitude is 7 and our vertical translation is -1. So, and again, this is a sine graph, so don't be caught out. This is the graph that goes up first and then down. So this is 180 here. This is 360, and this would be 90 up here. Okay, so that's 90. So these are the x values I'm talking about here. Okay, we've got 270 over here as well. Now, the magnitude of 7 is interesting. So I've drawn the sine graph, but of course this is slightly different. Everything's been shifted down. So in reality, I might just quickly adjust this. I can find the ruler. Okay, so I'm just going to change this line because, oh, right, okay, it's rubbed away too much. Right, okay, forget that. I'm just going to quickly sketch the sine graph here like this. Okay, basically it's all been moved down one, so it's just going to look slightly different here. Okay, it's just going to start in a slightly different place. The magnitude is 7. It's been shifted down by 1. That's the key idea. So let's go around solving it. Let's add 1 to both sides. Okay, so we've got 1 on this side, and we've just got 7 sine x on this side. Let's divide by 7. Again, I'm doing this relatively quickly now. I'm hoping that we're happy with this, solving to this point. The new thing here will be to do shift sine to get the inverse function of sine. And in our calculator, we're going to do sine inverse sine 1 over 7. And when you do that on your calculator, so shift sine 1 over 7, and that's going to be 8.2 to 1 decimal place. Okay, so what that's telling us is that this point, where it first crosses the x-axis, is going to be the point 8.2. Okay, so we're going to use symmetry here, but this time we're not going to use the symmetry of 180 degrees. What's important in the sine graph, so I might just zoom in and draw you like a little bit of this sketch. Okay, what's happening is it's crossing at 8.2, and then it's coming back down. This highest point is 90. Okay, so this goes on to do the rest of the sine function, but this what we're seeing here, it comes in at 8.2, it reaches its maximum here at 90, and then it comes back down, and we're being asked what this point here is. So you might have spotted that the question then is, what's the difference between 90 and 8.2? So 90 take away 8.2 is going to be 81.8. And so what we'll do is we'll add 81.8 to this side, and that'll, because it's symmetrical, that'll tell us what this value here is. Okay, so if I just add 90 to that, that's going to give me 171.8. So my other value of x is 171.8. Okay, so notice that the difference between sine and cos is with the cosine, it was 180 that we had to use. But because this graph is different, we're using 90, and it's 90 because this is where the symmetry is between the two sections. So, you know, if you want to see what the symmetry is between this point here and this point here, the line of symmetry is at 90. So again, be really familiar with these graphs, and I do encourage you to practice sketching them out. Be in a point where you can just quickly sketch this and know that that point there is 180 and that point there is 90. Okay, and that the full thing is 360, because that's key. Okay, so we've got this question here. So I think what I'll do is make this a bit bigger so we can zoom. Okay, so here we've got a wind turbine has 3 blades as shown. Okay, the height of the tip of blade A, okay, maybe I'll use a different coloured pen. So the tip of blade A, the height of it, so in other words, how far away it is off the ground, can be shown in this by this equation. Okay, which is h equals, I'll zoom in a bit. Okay. Hopefully not that much. Okay, it's shown by this equation. H equals, there we go, h equals 40 plus 23 cos x. Okay. Now, you know, this is a formula. It's clearly, you know, it's got a cosine in it, so it's the sort of thing that we've been looking at. And what this says is, you've got an amplitude of 23, and then the entire graph is raised up by 40. Which, if you think about it, makes a lot of sense, because if you're talking about a wind turbine, this wind turbine is not going to hit the ground, is it? If this is spinning around and catching the floor, it's not a very good wind turbine. So it makes sense that you've got this vertical vertical translation. I was going to say something else there. Vertical translation of 40. That means that, you know, you've got this at the very least, you've got this height of 40 up. Now we'll talk about, you know, the effect that this cosine is going to have, because in fact cosine can be negative, as we're going to see. So the first thing is calculate the height of the tip of blade A after it has been turned through an angle of 60 degrees. Well, 60 degrees is the angle, so all it wants you to do for part A is just use this formula. So it's h equals 40 plus 23 cos 60. The reason I'm writing in 60 here is because it gives me the angle of 60 and says, hey, what does h equal if x was equal to 60? Okay, so again, I think that question looks scary. Personally, if I was sitting a test and I saw that question, a little bit of me would be thinking, how am I going to do this? But, you know, just take it slowly. They've given you a formula. They've given you something to put in the formula. We're not going to panic. And our answer is 51.5. And all I've done is type this into a calculator. Okay, so that's part A. Part B says, find the minimum height. So let's imagine this carries on going round. The minimum height is here. Okay. You've actually got a couple of ways to do this. You could say, well, actually, that's an angle of 180 degrees, and you could, in your calculator, type 40 plus 23 cos 180. Okay? And if you do that, you're going to get 17 as your answer. The other way to do this is to think to yourself, okay, I know some things about cosine. I know what the smallest cosine can be is -1. So if this equation was 40 plus 23 times -1, that will be the smallest this equation can be. And again, if you type 40 plus 23 times -1 into your calculator, you will get 17. So those are the two ways to do this. You either say this is an angle of 180 degrees and solve it just like you did in question A, where you just put 180 degrees in as your angle, or you can use this and think, okay, cos x equals -1 is the smallest it ever gets. So that must give me the smallest answer. It's really up to you, and it'll just be based on your personal preference which way you go on that. Now, question C is the solving the equation question. So if I move this, it says calculate the values of x for which the tip of the blade A is 61 meters. So what it's done is it's giving you, I might just clear a bit of space here to answer. Okay, what it's done is it's giving you a height. So if I type this here, the height, it is telling you that the height is 61. So if I write this equation out again, I can write 61 equals 40 plus 23 cos x. All I've done is instead of writing h, I've written 61 because it gave me the height and it wants me to solve for x. So again, the first thing I want to do really is take 61 from both sides. And the reason I'm doing that is I just want to get a feel for what this, what this graph would actually look like if I was to plot this. So that would give me 0 equals -21 plus 23 cos x. I'm going to draw my degree symbol there. So what this tells me is this graph would be a magnitude of 23, but vertically translated -21. So I will just quickly draw what I think that would look like. It's going to be this bucket shape like this. But it's going to be quite, it's going to be shifted down quite a lot. It's been moved down -21. So now what I'll do is I'm going to solve for this. So I'll add 21 to both sides. I'm going to divide by 23. And then I'm going to use the inverse function on my calculator to find out what x is. Okay, so that's going to be 24.07. So I'm gonna write that to 24.1 here. Okay, 24.1. So again, what we've learned here is this is going through at 24.1. We've got this symmetry at 180 degrees. So the distance here is 180 take away 24.1, which is going to be 155.9. So if I add 180 and 155.9, that's going to tell me this distance, 180 plus this, will give me this other point, which is what I'm looking for. So if I do that, I'm going to get 335.9. Okay, now I appreciate this is pretty hard, and what I will say is this windmill questions is, it's as hard as it's going to get, I think, for this kind of question. There's a lot to it, but notice again The importance of knowing the graphs, that's really the key idea here. Understand magnitude, apologies, understand amplitude, understand frequency, and understand vertical translation. Understand those things and make sure you can plot the graph. And from there, everything is much easier. And above all, practice, 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 because that makes the difference.